Alright, so what I wanted to double check and kind of point out is in the bottom corner down here, we see that it says fully defined. Now, you can see the endpoints here of these construction lines are blue, and that's because to fully define a sketch, we're not really worried about the construction lines. These construction lines aren't actually creating any geometry. They're just there as reference. In this case, we're giving an angle reference to one of these spline handles. So I just wanted to point out that I gave this line a 500 millimeter dimension for a reason. I'm just going to go ahead and create another sketch on that tail plane, grab this line, and I'm going to convert it. Now I normally use the hotkey N, but you can grab it up here, and you can also see if you just hover the mouse over, it'll pop up and it'll tell you convert entities is the letter N on the keyboard. So I brought that line in, and that is my sketch. I'm going to rename this helper line, and this should become apparent here shortly. On this midplane right here, I was gonna recreate this, but I'm gonna go ahead and just convert it over. I know these are straight lines, so I know these endpoints are gonna intersect. So just to save some time, I'm gonna drag that over. All right, now the next step I want to do is going to be to create some helper surfaces. A lot of times in surface modeling, you are going to create extra surfaces to drive the curvature of the surfaces you actually want to keep. What I'm going to do, we created this top line on the right plane. I'm going to go ahead and extrude it 500 millimeters away from these curves here. And for this bottom line, since we're talking about an 8-degree angle off of the top plane, I can't just extrude that down. So this extra little line here that I created is actually going to serve a purpose to create a boundary surface. Boundary surface is a very, very powerful tool. That and filled surface are probably the most used in most of the things that I draw. Boundary surface, you can kind of think of it as a loft, with the exception that you don't need a start and end cross section. You can see here in the properties we have direction 1 and direction 2. We can use 2 curves or any number of curves in direction 1. For instance, let me clear this. I'm going to go from this curve to this curve. Now, without having any guide curves or any rails or anything, we can create that surface there. Now, what I want to do is use this as direction 1, and in the direction 2 box, I want to select that line. Now, you can kind of see that we still have that reference line behind it, so I'm going to have some trouble selecting that. I can either go to select other, and you can see we have the helper line, and the reason I renamed that is because now we don't have to figure out, was it sketch 4, was it sketch 5, and I can just select that. So here you can see we've created a boundary surface, and it's essentially just going to be an extruded surface. It just happens to be in a different direction. So go ahead, and now we have these 2 helper surfaces. We can go ahead and create a filled surface. We could also create a boundary surface. In this case, the difference is really minimal, if any. And I'm going to just go ahead and select all 4 of these. And here's where the benefit comes in. If you look over here in the properties, we have 2 edges and 2 sketches. These edges, we're going to go ahead and in this drop down box we have contact, tangent, and curvature. Now if you remember my note a few minutes ago, I said we have G0, G1, and G2 continuity. G0 position would just fall under that contact. G1 is the tangent, and G2 is curvature. One important note is that our sketches on the end, those splines we created, we added a curvature relationship up here. Now, you're going to find that if you have these extra rails or these extra sketches in here, and you put a tangent relation to them, you're going to want to understand the difference between the two, and when you're creating your surface, you're going to want to stick with that same relation. This other edge down here, if you remember, we had a tangent relation with that line that we use for this boundary surface. So I'm going to go ahead and apply a tangent relation there and OK this. Now instantly you might see, okay, well, this really doesn't look too good. It's not really what we wanted. It's kind of bulging out here. So let's go back in here and see what we have here. Alright, so we've got optimized surface, apply to all edges. No, these aren't really changing anything. Let's go back in here to the curvature and change that to tangent. Let's see what we get. Well, no, we're still getting some funniness here, and that's not really what we want. And you have some more options down here. Fix up boundary. Yeah, these aren't really going to change anything. Alright, well, look at that. We changed that top one to tangent, and that's more what we want. Alright, so let's OK that and take a look here. And yep, I mean that's more what we wanted. When we tried to use that curvature relationship, we got some interesting geometry. It was following what we wanted on the edges, but it was trying to bulge out, and that's the interesting thing here, because we're using these flat extruded surfaces as references. Curvature relation might not be the best option for you. You're really not going to get anything because you're not trying to match that curvature there, because there is none. And if we come over to the Evaluate tab, you have a curvature analysis option. You click that, and it'll actually give you this this color-coded view of your surfaces here. Now, one interesting thing is if you drag the mouse over the different colors, it'll actually change the radius of curvature for you. And you can see down here, these two flat surfaces are black. There's zero curvature, and you get that when you drag the mouse over them. And when you come look at this blue surface, it follows that curvature here, and it blends down into this other. And the same thing, it blends back over here. And that's what you want to see. When we mirror this across the right plane, we're going to get a really nice transition between these two surfaces. So what I want to do right now, I'm going to turn that curvature off, look at my surface bodies, and what I want to do is rename these, the two surfaces I used, and call them helper surfaces. Later on in the model, I'm going to delete them, but for right now, I'm just going to leave them in the model so the feature manager isn't filled up with delete body commands. They're not hurting you being there. You just hide them. You don't have to worry about them, and you can deal with them later. And one thing I want to do, I'm going to go ahead and mirror this across the right plane, just to take a look at things. Alright, so that, I mean, that looks pretty good. Obviously you have that seam there because they're two different bodies, but you just want to make sure that you're on the right direction for the shape of this body, and I think it looks pretty good. I'm going to delete that mirror. I'm going to go ahead and save this. Alright, hopefully you guys are still following along and you aren't sleeping at your desk. We're going to move on to the next part. Alright, so next we're going to build the section here. This top piece is actually going to be in 3 sections. So we're going to build up to that next plane that we created. So on the right work plane, go ahead and start a new sketch. And let's take a look at some things here. Alright, so we have this vertex. We can go ahead and create a spline starting there, and we want to run it down to our surface here. I'm going to go ahead and I'm going to apply a tangent relation here. Now you might be wondering, didn't you just say that you have to be careful with tangents and curvatures, and yes, you do. The reason I'm using tangent here is because this surface in this direction is straight. There's no curvature that we have to worry about. If we add a curvature relation here, we might get some funny things like we did with that first surface. So you really want to take a look at what you're working with, your surrounding geometry, and just make an educated guess.